Hello students, welcome back to the another video lecture of ADA subject. Currently we are learning unit number 2, which is analysis of algorithm. In that, in previous video lecture we have discussed about recurrence relation and solving of recurrence relation. In previous video lecture we have solved our recurrence relation by backward relation method. So, in this video lecture, we are going to learn about forward substitution method. So, for it, in previous video lecture, we have seen this type of code. From this type of code, we have made a recurrence relation, and on that recurrence relation, we have learned that it can have two results. One, tn minus 1 plus 1 in case of n is greater than 0, and 1 in case of n is equal to 0. So for this type of recurrence relation we have also discussed that we have two methods. One is substitution method and second one is master method. So in this video lecture we are going to learn about forward substitution method. So in forward substitution, this method makes use of an initial condition in the initial term and value for the next term is generated. This process is continued until some formula is guessed. So this is basic one we can say definition type, but we have to know these three things only. First, take the recurrence relation or recurrence equation and initial condition. Second is put initial condition in equation and look for a pattern. And third, guess the pattern. So let's take an example and understand forward substitution method for solving recurrence relation. So for that we have to solve a recurrence relation, and that recurrence relation is Tn is equal to Tn minus 1 plus n. Here you can see that our previous recurrence relation was Tn minus 1 plus 1, but here we have taken recurrence relation is Tn is equal to Tn minus 1 plus n. So for the recurrence relation we have taken our initial condition T1 is equal to 1. Okay, so after that if Tn is equal to Tn minus 1 plus n, so we have to put our initial condition into this equation. So if we take value of n is equal to 1, then our T1 will become 1. That is our initial. Now if we take n is equal to 2, then T2 is equal to T1 plus 2. In this case we have taken T1 means n minus 1, 2 minus 1 is equal to T1. So here our T1 is 1, which is here. So it will become 1 plus 2. So here you can say we have substituted a term here. So this is a term forward substitution. Okay. So in next case, if we take n is equal to 3, then that will become T2 plus 3. So here we can replace our T2 with 1 plus 2. Why? Because here our T2 is 1 plus 2. So here we can write our 1 plus 2 plus this 3. So it will become 6. So as you can say, T1 is equal to 1, T2 is equal to 1 plus 2, T3 is equal to 1 plus 2 plus 3. So as like this, if we consider up to the n terms, so our sequence will be Tn is equal to 1 plus 2 plus 3 up to plus n, means summation of 1 to n term. So for finding summation of 1 to n term, this is the equation, n into n plus 1 divided by 2. We can solve and check here it is correct or not. So if we take 3, so for 3 this equation will be 3 into 3 plus 1 divided by 2. So it will be 3 into 4 divided by 2 is equal to 12 divided by 2 is equal to 6. So by this term our answer is 6. But actually we can say our T3 is 1 plus 2 plus 3 is equal to 6. So by putting this equation we can solve our Tn. So we can say our equation or sequence driven formula is n into n plus 1 divided by 2. Okay, so by generating formula, if we multiply n with this bracket, so it will become n square by 2 plus n by 2. So in this case our equation is n square by 2 plus n by 2. So we can say here that is the order of n square. So in this equation means Tn is equal to 2n minus 1 plus n. This recurrence relation solution is of order of n square. So this is the method for solving a recurrence relation by forward substitution method. You can take any recurrence relation and solve this type of recurrence relation solution. Just remember that we can solve any type of recurrence relation by substitution method, means we can solve any type of recurrence relation by forward substitution and backward substitution method. In future we will see a method, that method will not solve all type of our recurrence relation. Okay, so that is it for this forward substitution method. Okay, thank you students.